Hello, everyone. Thank you so much. I'm Lisa Aguilar. I'm going to be joined by Simon and Francisco here in just a second from Sony Entertainment. So a quick little bit about DataRobot. DataRobot is the only pure-play, open AI lifecycle management platform for both generative and predictive. We've been focusing on nothing but AI for the last 10 years. We have over 100,000 users that have used DataRobot for all their AI initiatives, from well-known brands like Mitsubishi, who has used us in terms of their AI operations to optimize their entire processes, to retail organizations that you may shop at every single day, like 8451 or Kroger, to some of the biggest banks around the world who have standardized on the DataRobot AI platform for their governance and model compliance processes. And it's because of our expertise, both in AI and applying it as our platform, that AWS has recognized us as one of their technology partners of choice, specifically around the industry use cases that we can deliver. So let me talk to you a little bit about the DataRobot AI platform. First and foremost, we're about helping you streamline and unify the entire lifecycle. So we really don't care how many data sources that you have. We don't care what API or AI tooling that you want to use, and we don't really care where you want to put those AI models into production. This is really about helping you unify and standardize how you operate all of your AI assets, how you govern the workloads that you do, and then giving you the ability and the flexibility to build with agility. So I'm going to give you a quick walkthrough of the DataRobot platform so you can take a look at it. So I'm going to start off with our DataRobot documentation. This is our documentation. This is our website. We've included a new generative AI experience in this. So I did pre-cache this because the Wi-Fi at events is really terrible, as you know. So you can see here is DataRobot is not focusing on the ingredients. It's about helping you feel confident about pulling those ingredients together to give a right response to your users when they need it. And we do that through a couple of different ways. First and foremost, we have some safety nets, what we call our Gen AI guard models that you can include with your answer. So right here we have an answer. The response has been graded as correct, and why we believe it's correct. This is to signal to your user on if they should be paying attention to this response or not. Plus, you get all of the AI citations in here. So one of our customers, Keller Williams, is actually doing something very similar with their training experience for all their real estate agents. What they're doing is they're creating this kind of search experience, and then they're using different types of what each one of these is, as you can think of as a vector database, for their video training or their interactive training, and then be able to get that experience. The other thing that DataRobot does is we have a human feedback loop system. So in this answer, you as a user can then tell the generative AI solution if you think this is correct, incorrect, if you think it's incomplete, or if there is no answer. So how did we get here? So first and foremost, it's about having a centralized view of everything that you have in production. So this is the DataRobot AI console. So think of what Salesforce has done for CRM data. You only have one single source of truth of all of your customer interactions. Now, where do you go when you need to see all of your AI assets in production? It's very difficult, especially if they're built on different systems or deployed to different systems. Think of this as a 360-degree view. Again, we don't care where it was built, how it was built, or where it was deployed. It's your command and control center to give you the exact visibility over the service health, the data drift, and everything else. Let's dive into one of these models. Let's do this Bedrock model right here. You're going to get a little bit of an overview on it. You're going to get some basic service health information. But most importantly, again, we're focusing on helping you solve the confidence problem with generative AI, not the ingredients. How can you feel that you can trust what it's going to be doing once it's in production? So right here, we have a couple of custom performance metrics that you can see with DataRobot. So you can see if there are like guardrail violations that are happening. You can take a look at your LLM costs and making sure that you're keeping those in control. You can even add things like how readable is this? This is a really important score for some of our financial institutions that are looking at research papers. They want the generative answers to be really readable. And then you can take a look at everything else. And you can start to set thresholds and alerts so that you can manage some of these things. So if your LLM costs are starting to get out of control, you can set those alerts and boundaries and go in. If you have bad actors that are trying to actually get a response that you don't want them to do, you can set those thresholds as well. Now, if we go back to that human feedback loop about the correct, incorrect, or incomplete answers, we're going to just call this one correct. Now, that's great, but how do you then go back and figure out what exactly went wrong so that you can fix it? This is where DataRobot, again, the AI Council gives you a big visibility. So I'm going to give you a quick walkthrough here. These are all your incorrect, no answers, correct, or incomplete answers over time. Now let's say we want to focus in on just the incorrect answers, because of course those are the things that we want to make sure are working well. You can start to take a look. You can go ahead and pull it up. You can see, are the actual answers getting worse over time? Are your users telling you that there's a signal that you need to go back and fix your generative AI model? With DataRobot, you can actually see that. So how do you then take that information and figure out what part of your process that you need to fix? Again, we make that very easy for you. So think of this as your generative AI lineage. There's no other better way to describe it other than that. You get a full view of what the predictive score that it believes it's going to be for something that's maybe incomplete or something that's incorrect. You have all of the actual context, plus you have all the prompting strategy. Now, what about that human feedback loop? People that are telling you that something's incorrect. You can go ahead and you actually capture that information as they're giving it to you. So you can see if an answer was correct or incorrect. You can match those two up. You can actually go and take a look and see, do I need to go and update my vector database to make sure that my generative AI models are performing the way that they should be performing and giving correct answers. This is how you get that confidence that you can rest assured that your generative AI solutions are providing value to your users. Now, what about building? You heard this in the keynote. Optionality is truly key. There is going to be no one winner today. So with DataRobot, we have a multi-provider LLM playground. You can actually mix and match and choose different types of models that you want. You can actually bring your own as well. But comparing these models against each other is what's very tricky. So what we have is a nice comparison playground. So I have 3 different Titan AI models that I've built here. While those are loading up, I'm going to look at the information. As you can see, I have different system prompts. So you can try different system prompts, different chunking strategies, different vector databases. So for this one, I said, explain it like you're speaking to a child. For this one, it says, explain it as if I'm not a data scientist. And this one, I just tried it by itself. I have 2 vector databases here and none here. You can easily see them. Once you've picked the right one, you can quickly put that into production. DataRobot compiles all of those pieces together to make it very easy for you to register and then manage those pieces once you do have it into production. So why did we build it this way? AI is moving faster than you can apply. If you think it's changing faster, you can't keep up, it's because it is. RAG was a term that didn't even exist 7 months ago, and now it's become very common. Hallucinations is now, I think, Webster's dictionary word of choice, and it didn't really exist in our language. So you need the ability to have an insurance policy against making sure that you're not actually getting into AI sprawl, because you have so many different LLMs, you have so many different people building, and they're building across different aspects. Also, most organizations have more than one cloud deployment, so you need to be able to unify and standardize how you're looking at your entire AI ecosystem across all of them. And this is where DataRobot helps give you a really strong, flexible, canonical AI stack and backbone. So think of this as your insurance policy against technical debt and infrastructure bloat, because we can handle both generative and predictive. We can help you build with the agility and the flexibility, so you can be able to pull any proprietary APIs, you can use any open source, you can use any cloud model that you want. You have your playground and your experimentation to be able to test different strategies together with your grounding data. And most importantly, you can be able to orchestrate all those component pieces really neatly and organized together. And what's best is you can hot swap those components out without breaking your enterprise-grade production pipelines inside a DataRobot, so you have the flexibility to pick and choose as you like. We help you operate with confidence and control. I showed you just a few of the safety nets that we have involved. That human feedback loop, those generative AI guard models, the ability to see all of those pieces together, and then deep dive into each one of those pieces to understand where you need to go and investigate to adjust. And of course, it's about being able to help you govern with full visibility and transparency. So again, like I said, we don't care where you built it, how you built it, what tools you built it with, or where you built it out. Our governance layers are really helping you get full visibility of all your projects in flight, all your projects at rest, so those are the ones that are getting put into production, and then all of your projects once they're in production. All right, so with that, let me pass this on to Simon and Francisco. We'll deep dive a bit more.
Hello. Thanks, Lisa. So my name's Simon. I'm just going to talk a little bit about our ML pipeline journey and where DataRobot fits in. Oh. So when we began, 5-6 years ago in our fraud system, we were entirely on-premise. We had only a rules-based system. We didn't have any models at all. So when we wanted to move away from that, we wanted to keep, one of our founding principles is using managed services. So AWS obviously is a big part of that. We all use managed services wherever we can, but DataRobot, their AI platform, really allows the data scientists to focus on what they do best. So the DataRobot platform, it automates and optimizes a lot of the things that the data scientists do, and there's no more hand coding of models from the data scientists. So we have a joke in our team that whenever a new data scientist joins, they always think that they can hand code a model and that it's going to be better than the DataRobot output model, but so far we've had no winners. And everything that we built in our pipeline that Francisco is going to show in a second here, we always try to make it fully automated and reusable. So not just for one use case, not just fraud, but I'm going to talk about some of the use cases in a second, but let's make sure that we can reuse it for other use cases. So some of the use cases for our predictive AI, that's our bread and butter, what we've been doing for a while. We typically do the account security stuff, so account takeover fraud, and we do financial fraud, blocking people from using stolen credit cards on the platform, and we do that all inline and in real time. And then the same components we've used over and over for other things. So we're now using them to do forecasting for revenue for the store. We're using them to do payment optimization for increasing the acceptance rates for our credit cards. And then with the generative AI use cases that we're currently looking at, they fall into 4 different categories. So obviously everybody's aware of the search. You have a search chatbot, or a chatbot, sorry. The search one is interesting. So as Lisa said, we're doing basically that, but we're doing it in 2 ways. Internally, we're using it for better aggregating our documentation and allowing people to search on it better, more intuitively. And externally, we're taking all of the content that we have about all the PlayStation games and really allowing the user to search for a game in a way that's more intuitive to them, instead of the typical recommendation engine where we're trying to predict what games they might like. Seed the LLM with all of the data we have about all the games, and then allow the customer to ask questions and really pry into why this game, why they might like that game, why they might like this game and the other one. The associative reasoning is another interesting use case. So we have chats from our customer service agents and our customers, and we can do things like, what is a common reason that people are calling in that maybe our typical metrics aren't finding out? Or is there something nefarious going on in that chat? Maybe they're trying to bribe the customer service agent to give them access to a PlayStation account. So we can do that kind of things with the Gen AI. And some of the ways that we've gathered interest in those things is just doing a hackathon and getting some POCs going in the company and generate some interest that way. So regardless if it's a generative AI or a predictive AI project, KPIs are the most important part. So before you start the project, you got to know what your baseline is. What is the baseline that we're trying to improve from? If you do the KPI after you've done the project, it's too late. So these are some of the KPIs that we've used internally to justify our AI projects. Obviously, cost savings. The business impact, the revenue has been the biggest driver, but things like employee retention, something you might not think about, like if we automate some of the mundane tasks the employees do, it'll increase their retention in some of our departments. And obviously customer satisfaction from getting the answers that they want in a better fashion. And then how do we operationalize these new Gen AI models, right? So we got to think slightly differently from our current predictive models. So the infrastructure is different, right? We're used to, in our current inference system, doing sub 10 millisecond responses, but that's not appropriate for Gen A. So how do we make sure that we can scale that infrastructure out? Again, measuring the quality of the Gen models. How do we know that they're performing well against the KPIs that we want? Guardrails are really important, obviously, not only against unpredicted model output, but hallucinations and wrong answers. How do we control for that? Audits, obviously, and compliance. Upgrade. So once you put a model into production, how do you know that A, the model is still performing well and hasn't degraded, and B, how do you know that another model is going to be better than that model? How do you do that actual measurement? How do we know that this one should be promoted to production? And then finally, monitoring and alerting. So how do we know if something's going wrong with the current running system, and how do we get notified about it? So now I'm going to turn it over to Francisco to talk about some of the building blocks that we have.
Thank you, Simon. So I would like to share how we leverage DataRobot in AWS in our ML pipeline at PlayStation. Basically, we have all sorts of data sources in the company, and the first step, of course, is to prepare our modeling data set. Nothing to be said here. The fun actually begins with DataRobot when we upload our data set. Here I have a use case for fraud. So I have to specify the column I'm trying to predict. I have my label with good transactions and bad transactions. DataRobot can already identify that we are talking about a classification problem. And it shows us the distribution of the classes. And from here, we have to basically click on that start button. We don't really click anything. We leverage DataRobot's Python API to have everything automated in our jobs. But once you click on that button, DataRobot is going to start a process which is called autopilot. That process is like a tournament between models. It's going to start with dozens of model configurations and just a small portion of the available training data. And as the iterations go, it's going to keep only the best performing models and retrain them with more and more data. Here I have an example of what that process looks like. On the right, we have all the models that are being trained. Just to show you what one of those models look like, this is what DataRobot calls model blueprint. So it's not really about the model. It's also about the other steps that a data scientist usually has to perform, like dealing with categorical variables, with missing rows, performing hyperparameter tuning, all the steps that really takes a long time for data science to complete. After autopilot finishes, we are going to have this list with the models ranked by their performance. We can inspect the models in more details if needed, but at some point we're going to select a model. We leverage another feature from DataRobot which allows us to export not only the model, but the model blueprint as a jar, as a Java application basically. And we do this for a few reasons. The first one is to perform what we call a batch scoring. For our use cases, we have to simulate how the model would have behaved like in the past weeks or even months. And in order to cope with the scale that requires, we take that jar and we embed it in an EMR job. With the scores in place, we can compute the evaluation metrics and compare how the new models look based on the existing ones. At some point, either a data scientist or our automated jobs is going to figure out if a new model needs to be deployed. And if that's the case, we're going to take that same jar that we use for batch scoring and send it through our CI/CD pipeline to create a new version of our scoring service. When the new version is deployed, we can start sending requests from our inline decisioning service. And most of the features for the model are already in that request. But we also have some extra features that we fetch in real time. Some of those features are in DynamoDB, and some are computed on the fly in our aggregation service. With all the input in place, we can actually get the model scores, and based on our business thresholds, we will decide, for instance, if transactions should be accepted or not in the store. That decision is fed back to our data sources, so we can improve future iterations of the models. That's the overview. I think Lisa has a few final comments?
Yeah, just one closing slide. If you can advance it. Great. I think final takeaway is technical debt is an actual real threat, especially because things are changing. You really do need to look at how do you get an insurance policy to make sure that you're open and flexible in terms of being able to keep pace with the pace of change. If you just look at the last 6 months, what is the next 6 months going to actually bring us? We don't know. So you have to be able to have that agility. The other thing is there's a new level of preparedness that you're going to have to take on when it comes to operating and observing all of your generative AI models. It's very different. Data drift is easy. That's been solved. Figuring out what went wrong in the answer that was provided to you, that's a lot more difficult. So it's a muscle that you're going to have to develop. And last, we heard about this before, it's cost and ROI, and the value of these use cases is really going to be very important. There is a huge cost when it comes to generative AI. It's not like predictive, which is just time and labor. So making sure you're picking the right use cases and then you're managing those costs over time effectively is going to be key for you to scale. If you have any more questions, I know we can meet you guys outside, but we also have a booth 180 all the way in the far left corner, very easy. So thank you for your time.
Thank you, Lisa, Simon, and Francisco. That was very informative. Thank you. And thank you for joining.